Hello, I presume we're live already, so let's get started. I'm Svezden, and today we're going to be talking about Ethereum smart contracts. This is the second workshop in my blockchain series that I'm presenting at Hackathon of this year. Now, you don't have to have attended the previous one in order to benefit from this one, so it's all right. But if you did, good for you. And if you're actually looking on doing anything meaningful in the blockchain area, you absolutely must cover the previous workshop. It just gives you mandatory background. With that, let's get started. So first of all, please interrupt me with as many questions as you possibly can. This workshop is going to be very theory light, unlike the previous one. I'm going to be spending very little time talking. By very little, I mean like an hour. And please shoot as many questions as you can on the Slido here. You should see the same links shared around the platforms you're watching this. And yeah, we've got a wonderful workshop helper here called Marcus, who's going to be helping us with some of the questions as well. So welcome his responses as well. With that said, let me just give you some background about myself. Now, I've been working in the blockchain field for the past about 6 years or so. I've developed a number of interesting papers in the area. I guess something worth mentioning was design of a blockchain network for distributed machine learning. And also, I taught the first course for blockchain in Bulgaria, my home country, where I taught Solidity, which is basically the topic of today's lecture. So you could think of this workshop as a summary of this course, of its most important aspects. And this course costed quite a bit of money, so congratulations, you got some goodies. Cool, so let's get started. So let's just summarize the features of what a smart contract is. I'm not going to explain how these things work so far, but I'll just say what they do, okay? So what's a smart contract? Well, it's a piece of blockchain software. What's a blockchain software? Well, it's a computer program that someone wrote, like me, uploaded it to the blockchain, and because of that, it automatically gains some security properties. For example, smart contracts are trusted. What does that mean? Well, traditionally, applications are very centralized, meaning under the control of a particular server. So whoever owns the server can change stuff. Contracts don't have that limitation. They're not stored in any particular location. They're kind of everywhere, which means that whatever is in the code, that's the law, basically. Code is the law. So that's why they're trusted, because nobody has ownership over them. Nobody has the right to change them apart from whatever is already in the code, okay? They're quite easy to set up. In fact, you see that the programming language used there is very similar to JavaScript and Java in terms of concepts. You see that throughout this workshop, you yourself will be writing 1 or 2 smart contracts just in a few minutes. So I'm very excited to show you how you can do that quite easily. But nonetheless, contracts are quite expensive. In order to upload into the blockchain and in order to benefit from the blockchain security, you and your users of these contracts will have to pay up quite significantly, okay? And lastly, they're quite risky in terms of the fact that because the contract's code is the law, because you can't really change the code once it's out there, that means that if you forget a security vulnerability or a bug inside, it's game over for you because you can't change it. Because once it's out there, the program is its own boss. Okay, so that's why extreme care must be taken when you develop blockchain applications, which is a great reason for you to actually understand the blockchain theory in depth. Hence, reference to my workshop yesterday, where you can watch the recording from the Hackathon schedule. Okay, so let's jump straight into some actual interactive demos. Now, I'm going to be showing you this super basic program, basically as simple as it gets. It's a contract. I'm going to be telling you what it does, and we're going to play with it interactively in an online environment where you can also follow with me. And you're going to use that same online environment for some exercises that you're going to write later down. Okay, so I'm going to open this environment. It's called remix.ethereum.org. Now, I'm going to send it over to you guys so you can have the link. Otherwise, that's it. So Remix is basically an online development environment where you can write Solidity code. Solidity is a language that allows you to write smart contracts. It allows you to compile it, address any compilation errors, and also actually simulate your own blockchain, and then upload that smart contract in the blockchain and then test it out and play with it as if it was actually running in a real blockchain. But because it's in a simulated blockchain, you don't really pay real money to do so because it's only on your computer. Like, it's kind of fake. But it's a great testing environment. So, okay. So let's start with this. Once you open Remix, you're going to see a default workspace that actually comes with a few basic contracts, some code that you can actually start working with. That's one of the contracts it comes with. It's called storage, and it does a very simple thing. It allows you to store a number inside this contract, to set this number via a function, and to retrieve this number via a function. Okay, so good so far. And so let's just see what's up. So contracts are kind of like Java classes, where they have a number of variables, a number of state, like data, that they can store forever. Like, it's permanent storage state. So if you store a variable there, it's gonna keep on existing until your code overrides it. Okay, so you've got state here. In this case, we've got one variable declared, and then we've got functions. Okay, so functions are things which users of the blockchain can execute. So any function of a smart contract can be executed by anyone in the blockchain network, and these functions can change the state, can have a bunch of logic, and can do some quite useful operations depending on the context. We're going to see some better examples later, but now let's just see the fundamentals. So we got a contract, it's basically like a class definition, and then we've got the definition of a state variable. Now this contract only has one state, one variable, and its type uint 256, and its name is number. Now uint 256, that's a pretty weird name, isn't it? Usually in programming languages, you have things like int or uint. And what's this weird number at the end? Well, that is to make explicit some of the key differences between blockchain programs and normal programs. That is to say that integers, or most variables by default in contracts, are actually 32 bytes long. Bytes, not bits. Okay, that's 256 bits long. So that's humongous. Okay, you're never going to see a variable this size in a normal programming language. Okay, that's just gigantic. But that's how blockchain works, and there are many reasons behind this. I'm already anticipating some questions on the slide too. So yeah. So we've got this variable. It's a pretty big variable. We can store many things in it. So let's define a function. So let's define a setter of that variable. Okay. So that's the syntax of defining a function. The function name, parameters of the function. In this case, again, we're taking a parameter, and then we're just setting that state variable to that parameter. Pretty simple stuff. The function is public, meaning anyone in the blockchain can execute it. You can also make it private, meaning you can only execute it inside your smart contract, but we're not going to do that for now. Okay, pretty simple function. Okay, looks like traditional Java, JavaScript, whatever you're used to. And then the reading function, retrieve, is a bit more blockchainy because it has a bit more interesting stuff to it. So again, retrieve, it's public, but we're also seeing an interesting keyword here, view. Now, I'm not going to mention what it does so far. Okay, I'll just briefly say that you put view in functions which don't actually change the state variables of your smart contract. It makes things more efficient for various reasons. Okay, so if you want to return a value from a function that does a syntax, so you return, and then in parentheses, you list the data types that you're returning. So it actually allows you to return multiple things from the same function, which is a pretty nice bonus. So for example, I could actually list that I can return 2 things from my function. Okay. Okay. So I can modify this and do this, and this is going to compile pretty well. Okay. But what did I just do? So I said that this function returns 2 integers. One of it is unsigned, the other is signed. If you don't know the difference, that's fine. Doesn't really matter that much. And then I'm just returning the same thing. But let's just let's just go back to what it was before. So we're just returning the number. Pretty simple. So let's compile this contract. Here from the left side, we've got a compiler. We can compile it, and it's compiled. No warnings, except for some things here that we don't really care that much about at this stage, okay? Never ignore warnings if you're actually producing production blockchain software ever. Cool. So once it's compiled, we can actually try to simulate it, okay? So we're going to go to the Deploy and Run Transactions tab. We're going to see that we're using a JavaScript virtual machine, meaning it's a fake blockchain that you control. Because it's a fake blockchain, you can just start it with your account having a bunch of money in it, because it's a blockchain and it's your fake blockchain, which means that basically you don't have to pay for you to test your contract. Okay, so we're going to select this contract and we're going to click deploy. Okay, down here you're going to see that it got deployed. So what does that mean? Well, now this contract lives in my fake blockchain, and it lives at a very specific location. In fact, it has an address here. I just copied it. I can paste it over here. You see it has an address. So this is the public identifier of the contract. Anyone who knows that number can access that contract and can call any of these two functions. Of course, this is a fake blockchain, so nobody besides me can access it, but traditionally that's how things work. Okay. And we've got some nice buttons to simulate a user calling some smart contract functions. Again, anyone in the blockchain network can do that. So in this case, we can call the store function. We can say number 6. We can call it by clicking here, and it's called. It didn't really give us much feedback, but it's done. Usually there's supposed to be a log here, but now it's not really shown. So yeah, things break quite often sometimes. But it got executed successfully. And the way that we can see this is if we call it a retrieve function, it's going to give us a result. That's 6. That's nice. Cool. Cool. So yeah, we just published this contract and we just executed some of its functions. That's pretty cool. So let's just go back to the slides. Okay, cool. So let's start actually explaining what's up with these smart contracts and what's cool with them. So let's start with the traditional example of banks, right? If you're sending money, that's a very centralized system. Banks control everything. They control if you have the right to hold money, to send money. They control the fees and everything. Basically, very centralized. It's kind of the same thing with applications. If you're using some service, you're talking to a server, and that server determines everything. It determines, are you able to use the service? What happens with your data on the server? Who has access to your data? Who can modify your data? It's very centralized, and you have to therefore trust the owner of the server that things are going to be running smoothly. And that usually works in most cases, and in most cases it's actually quite fine. But in some quite more critical cases, you really need to not trust a particular third party, and in which case blockchain comes. Just like Bitcoin allows you to send directly money without actually going through a bank, Ether allows you to do the same with computer programs. Now let's take this example. If you have this website that pretends to be a voting system, would you actually trust it? Or would you start asking yourself who actually owns this site? Or what if someone hacks the server or something? Or you're not particularly sure if you can actually trust them counting votes quite fairly. So what Ethereum does, it allows you to write normal computer applications, such as, for example, vote counting software, where you can publish them on a blockchain, and from this they benefit from the blockchain security. What does that mean? Well, it means that an application gets executed on millions of computers at the same time. Your application gets executed on millions of computers at the same time, which basically means that it's not in a single one place. So you can't really change it, right? If If the code says that this should happen, then this should happen, and that's it. Code is the law. Ethereum is the second biggest cryptocurrency. That's quite an outdated photo already. And let me just give you a timeline of my incredibly lucrative investment decisions, personal investment decision with Ether. So I started working with Ethereum about 2016. That's when Ether was about $5. Okay. And I was working on a very nice project involving this, and a company decided to pay me $2,000 for it. So in Ethers, that would have been about, well, 200-ish Ethers at the time. Quite a bit, quite nice, or 200-300 Ethers, something like that. But I said, you know what? No, give me cash instead, because what if the Ether falls down and I'm going to lose like half of my money or something, and that's not good. But clearly what happened next is that the Ether jumped to $2,000 out of 10, which would have easily given me enough capital to buy one apartment in Bulgaria, one apartment in France, one apartment in Ontario, maybe 2, 3, or 4, or 5, I don't know. But anyways, that didn't happen. So Ether was 2,000, and then I decided to clearly that now is the time to go in. So company came to me again, and they wanted to send me some money again, and I was like, yes, give me Ethers. And then Ether went down 15 times, which is what naturally happens. So while I may be able to teach some pretty good blockchain, don't necessarily take very good investment decisions or advice from me necessarily. Okay, so let's get going. So I showed you a pretty simple contract, and now generally contracts that are useful contracts which actually give value to people are a bit bigger. So for example, this one is a contract which, again, pretty small, only 60 lines, allows you to hold an election, all right? Meaning you've got some people who have the right to vote, you've got n number of proposals, and these people vote on a particular proposal, and that's it. And not only that, but you also have the right to delegate your vote to someone else, so someone else can vote on your behalf. And then you can count the votes and you can see who won this with total guarantee, total security that nobody cheated, that nobody invented some votes, that nobody voted twice, that nobody who couldn't vote voted, yada, 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 at least from the blockchain side of things. And all that in 60 lines. If we have some extra time, we're going to get through this contract as well. We're going to explain what's going on. But for now, I'll move on to give you more time to work on your exercises. Okay. So clearly, writing contracts is quite easy, and it's quite modern to do that, right? You can, if you've got a startup, you can just scream at your investors that you've got a crypto contract, and they'll probably give you money. And nonetheless, contracts have pretty significant disadvantages in terms of speeds, in terms of risk, in terms of security of whether they have a bug or not, in terms of cost, and in terms of scalability. And you really need to have a very good reason as to why you're using a crypto contract in your project. If you don't know very, very well what's the added value of a crypto contract in your project, you probably shouldn't be using it in the first place. If it's just cool, if it's just nice, sure, but it has some very big disadvantages. And are you actually benefiting from the blockchain security? I've seen so many teams, so many projects just use crypto contracts and they don't really understand why, but they use it because they're cool. So yeah, we must think very critically about this. But with that said, I'll continue with a very nice example of how you can define your own currency. Now I'm gonna share you this link, but you don't necessarily need to access it right now because I've got everything set up here. So what I'll be showing you is a very, 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 very cut down version of a coin contract that allows you to define your own currency and basically use it and allow people to hold money in it and allow people to send money in it. Now, what do I actually mean by your own currency? I don't mean something that has any relation to ethers or dollars or any kind of existing currency. I'm going to show you the exact code of exactly what's happening here. And then we could discuss and then figure out why this could actually be considered a currency. So let's see what this contract does. So again, let's start by reading its state. So in this case, we've got two state variables here. Okay, we've got something called an address. Now, an address is a special data type in Solidity that allows you to hold the identity of either a user. So every blockchain user has an address. Like this very long hexadecimal. No, not this one. That I showed a few minutes ago was the address of the smart contract deployed in my fake blockchain. This is also an address that can be stored in that variable. Okay. That variable is public, which I'll tell you why in a bit, and it's called minter. So what does that mean? Well, I just want to store the identity of a particular person in my contract. That's okay, cool. And then I actually need a data structure where I can store who has how much money in my currency. Now, I don't necessarily need to actually have any real world definition of my currency. In fact, all I'm doing here is I've got a mapping, a hash map, right? A key value pair between an address, meaning the identity of a particular blockchain user, and an integer. That's it. And that's called balances. So this map can store for any particular address. It can store one value of a balance, and that's it. uint for unsigned integer. And if I want to be more correct, technically speaking, I should say uint 256 to make it explicit that that's the size of the variable. These are the better coding standards of Solidity, because uint is actually the same as uint 256, but it's less obvious as to how big it is. Okay, I'm using it here because it's short and pretty. But I'll do that. Cool. Then I'll just skip this section here. If you want, you can ask in the slide what this does, but it's not that critical. Okay, so contracts have a constructor, and here we're going to do a very fun trick with that constructor. So what's a constructor? Well, it's a piece of code, it's a function that gets executed at the moment this contract is uploaded to the blockchain. That's it. But it has some fun key properties. First of all, because it's a function, within every function, we have this special variable called message.sender. It's a keyword. It's a variable that gives you the address of the person who called that function. It's that simple. It's the sender of the thing which called your function. And the constructor is also a function, but because it's a constructor, and because how Ethereum works, it is always called by the person who uploaded the contract to the blockchain. And you need someone like a human with an account on Ethereum to upload that contract on the blockchain. And that person has an identity, of course. And in this constructor, we can get the identity of the person who uploaded the contract this way, and we can store it in our variable, in our state. We call it a minter. Why? Well, because this contract is written in a way where we actually want to give extra privileges to the person who uploaded the contract. So we want them to be able to do more things inside our contract than normal people. So we need to actually store who they are first. Okay, so that's the constructor. And I'll go back to the Q&A literally in just a few minutes. So I hope I'm not seeing a complete fire burning there. Cool. So what's this function doing? It's a mint function. What does it do? Well, so far we've defined our data structures, but we haven't really essentially initiated our money supply here, right? Nobody has money so far, or at least we didn't see this in the code. And that's because we want to have this special function which allows the minter to increase the money supply, which means that it allows the minter to just create some money out of thin air and assign this amount of money to a particular account. Okay, but we only want this function to be called by the minter. Okay, not by anyone else. And let me show you how you can do that. So first of all, this function takes two parameters: the address who's going to receive the newly created money and the amount of that money. Again, I'm not talking about actual money here because these are just some numbers inside my smart contract. But we're going to see a bit later why this might actually be considered a currency. Okay, so the first step in our function is to make sure only the people who have the right to call it can call it. Okay, in this case, I said that I want this to only be executed by the mentor. And we can achieve this with this expression. So I mentioned that message.sender always gives you the identity of who called the function. So we want to make sure that the person who called the function is the minter. Okay, and Solidity gives us a very nice helper function require, where you can pass it a Boolean expression, like something that evaluates to true or false. And if the statement is false, then it's going to throw an exception and it's going to stop executing that function. So pretty useful here and pretty clean. Okay, so the only way that we can continue executing this function is if the caller is the minter. Okay, we also want to place some restrictions on the amount. Let's say that we want it to be less than a particular value. Here, just 1e60 means 10 to the power of 60. So a pretty big number, but again, just a restriction on what are the allowed values for this function. Like, and lastly, last line is essentially the whole body of the function. Like, what does it actually do? Well, it takes the balance under the receiver address and it just adds the amount. But that's weird. Well, first of all, usually in programming languages, if you have a variable or a map, and usually before you essentially access the value at this key and then add something to it, you usually have to initialize it. So usually you would do something like that to initialize its value and then add to it. But here we see another fun feature of Solidity, that everything in its memory by default is always initialized to 0. Anything. So we don't really need to initialize anything. We can just take the balance of the particular receiver, and we know that this, if it hasn't been touched before, it has to be 0, so it's already initialized, and we can just add the amount to it, and that's it. That's it. Again, we're not actually working with real money. We're just shifting some integers around in this map. That's it. Cool. So that's the mint function. And then we want, well, distributed currency, which means people should be able to send money. So we've got a send function, which allows anyone with money to send money. So therefore, if you want to send, you probably want to have, there a receiver and an amount. Okay. So first of all, if you want to send money, you should have that money, right? So we have to check that if the requested amount is less or equal than the balance of the person who called this function, okay? Otherwise, we have to throw an exception and we can print this error message. Cool. So now, clearly we have enough money, so we can just subtract this amount from the balance of the sender, of the caller of the function, and then add this amount to the balance of the receiver. And that's it. I'm going to just ignore this line. That's it. This is literally our entire currency. We just have a mapping of balances, and people could just shift these numbers left and right. But it's completely trusted. What does that mean? That, well, once this is published on the blockchain, everyone can trust that this code does exactly what it does, and it's not going to change in the future. It does nothing less, nothing more. So, and yeah, if for example, I don't have a minter, like if I just don't have that function, okay, and I just declared in the constructor this, what does that actually do to my currency? Well, it means that initially my currency starts only with me, the creator of the currency, having 10 to the power of 10 money in my account, and nobody else has anything else. And anyone with money has a right to send money. So what does that mean? Well, that means that we have a constant money supply in my currency. Meaning at no point in the future of the world will the total money in my currency ever change, because it's not possible within the code. The code doesn't allow this. The code says exactly these things, and that's exactly what's going to happen. And you see how, in order to have a currency, you need trust. And you see how with code that never changes, you can have that trust. And if, for example, I connect this coin to my startup, for example, let's say I'm offering you a very good product. I mean, an incredibly good product that you really want to buy. But let's say I'm only accepting payments in my currency, in this coin thingy, meaning you would have to somehow acquire some number of points here, and you would have to call this function send to my account, and then I'll give you my product. So if that's the situation, then you would be clearly willing to actually exchange Canadian dollars, for example, for having some balance in my currency. Even though it's just numbers, for you it has value because you can use it for something. Okay? And welcome to the world of crypto tokens, initial coin offerings, and everything else alike. Okay, so let's play with this a bit. I've been talking for too long. I'm just going to do a very quick demo of how this contract works, and then I'm going to just give you an exercise, and I'm going to start asking questions. Okay, let's go and compile it. So it compiles, cool. And then we're going to go to the deployment stage. We're going to select this contract coin, and first of all, I'm going to remove the previous contract, and I'm going to deploy this one. What happened? We just deployed my current contract in my fake blockchain, and we have my send function. Now we're also seeing two other functions here that I never actually defined in my code. I'm saying balances and a minter function, and they're never here. That's actually me using one of the other convenience features of Solidity. That is, if you have a variable and you declare it public, Solidity automatically generates a function, a getter function for that variable. So automatically a function that just gives you the value of that variable. So by declaring the minter, I just have a function called minter, and I can call it, and it's going to return the minter. In this case, that's the address of the account with which I deploy this contract. I can verify it up here with the settings. You see, I've got an account here. So this is the first account, the currently selected account in the drop-down, meaning from this blockchain account, I just deployed this contract, and I can verify that my address is stored in this variable. Beautiful. Now, with mappings and more complicated data structures, you can still declare them public, and Solidity is actually pretty smart. Because this is a mapping, you can't just return the whole mapping, right? It's a key value pair. So it creates a function where you give it an address, and it gives you back an integer. So let's actually check this. I know that I should have a what kind of money under my account. I'm just going to copy my address here. I'm going to paste it in the address parameter of that function. I'm going to call it. And guess what? I got this number of money in my currency. That's the result. So I just confirmed that it worked. Beautiful. Now let me actually send some money to someone else. Okay, who's that person gonna be? Well, let me just. So you see how in my fake blockchain I've got a bunch of accounts here. So I can just select the second account. I can copy its identity, and I'm gonna go back and select the first account. Why? Because I wanted to have its address, and then I'll be able to send it. So I pasted the address here, but I also have to present an amount. So I'm gonna do a comma, space, and then let's say 10. Okay, and I'm gonna execute this. Again, not much feedback. It is what it is. Now I can double check my balances, and you can see my balance has fallen down by 10. Exactly what I expected. And I can paste the address of the second account which just received money, and I can check it again, and the balance is 10. Again, I hope I'm not speeding too much through this. I hope that you're managing to follow along. But I'm done with the demo. Right now, I'll just give you an exercise, and I'll start answering questions in case something needs to be fixed. Cool, but I really hope that you managed to see a nice demo of something slightly more practical, but still very simple to code in Solidity. Okay. So next thing, I'm going to give you an exercise. Now, please, I'm going to give you some time for this, like say 20, 25 minutes. You should have enough time to do this by Googling some stuff. Okay, so I want you to create a very, very simple contract that has a state variable called counter of type uint, and then it has a function that will increment this counter by 1, but with a restriction, only if called by the owner, meaning by the person who created this contract. Usually in blockchain land, we call this person the owner. So that's it. Otherwise, it should throw, like it should blow up, right? It shouldn't increase the counter. Okay. Also, you should write a function that allows me to actually read the counter, or allows anyone in the blockchain to read the counter. And as a bonus task, you can also add integer overflow protection. Now, you can go and look up what's integer overflow and underflow, and therefore you can see what kind of logic or code you need to add to protect against this potential threat. For anyone who's more advanced in Solidity, yes, I know Solidity has overflow protection by default now, but it's still a nice exercise. Okay. That's it. I'm going to stop sharing. I'm going to give you a link to this exercise as a document in case you want to refer to it. And I'm going to start asking questions. Okay, you should shortly see the link in your streaming platforms. This includes 2 exercises. I'm going to present the second one in a bit of time, but if you're fast enough, you can go there if you want to. Do whatever you want. Let me take a look at the slide. Okay, so questions. Okay, I'm just gonna, Mark has already helpfully responded to many of these questions, so thanks for that. I'm going to just check what hasn't been addressed yet. So someone asked, what if I send tokens, I guess in my token contract, to the address 0? Then there will be fewer of them. So actually, very nice thinking here. Indeed, that's the case. Yeah, actually, I'm not sure about whether the value 0 is actually a valid value for the address, for an address type. Because I think I saw at some point that this got banned. I might be completely wrong. So either, yes, you would be able to send tokens to the address 0, and then, yeah, that's it. Because address 0, clearly nobody owns that address. Like yeah, nobody could technically have that address. So you're basically throwing tokens away, and this is how you could reduce the token supply. So good cat. So someone asked for the source code of this workshop. I'm not sure exactly what code you're referring to. Oh, if you mean the coin contract, yeah, Mark has replied with this link. Thank you a lot. Otherwise, what other code might I send? All the other code examples are available by default on Remix, so you should be able to see it. So great question by Ryan. What happens if I would want to change the functionality in the future? Would it be possible? Well, by default, no. And that's the whole point of it, is if you as the developer have the right to change the functionality in the future, then how is that different from you having an application running on your server? Because you just have the same right to change it at any time you want to. So if you have that power, you technically don't really benefit from the blockchain security. Like, why would you have a smart contract in this case if you can just change whatever you want with it? Because if you change the code, you can change anything inside its data, and you can do whatever you want with it. So it becomes quite centralized. However, there is a significantly growing area called around the upgradable smart contracts, because it's actually quite important in some cases for developers to have the ability and the right to change some of the code. We've seen too many examples in the past where people have lost tens, if not hundreds of millions of dollars because of a tiny bug in a contract which could have been prevented if the developers had the opportunity to make an upgrade. But again, it's a very fine line between security, decentralization of the developers not being able to change whatever they want, and that flexibility that you need to fix problems. Now, this is actually a research topic that I'm working on right now around upgradable smart contracts, because currently in the field we've got things called proxy patterns. You can look it up, proxy pattern. That's the most widely accepted way that you can write an upgradable contract, but it's too centralized, I believe. And now I'm working in ways that you can make it more secure, more reliable, more trusted, but the developers can still fix bugs. Someone asked, what does the Pragma Solidity mean at the top of the code? And that's a good catch. Every line of every contract that I showed you so far starts with something that says Pragma Solidity and then some expression there. That's actually an expression that says for which compiler version is this source code written for. Okay, so it's very important because Solidity changes all the time, and some versions have breaking changes, meaning the behavior just changes by default. For example, very recently, integer operations, for example, adding two numbers together, changed. And now they actually do logical checks in case there is an integer overflow. Now, if you don't know what's that, it's all right. But what it means is that sometimes when adding two numbers together, you might get an exception and the whole thing blows up in the current version of Solidity, whereas in the previous version of Solidity, it would have been perfectly fine and it would have been accepted. So that's why it's very important to declare the exact version with which you want to work with. And if you're confident that your contract can work with a range of versions, you can code that in as well. For example, in my coding example, I believe I've got I'm saying that it works between 0.7 and 0.9. You can do that. So Jacob just sent an address full of zeros that ends with dead on the Ethereum blockchain, and it has like $42 billion right now. No, wait, no, yeah, 42 billion. No, literally no, wait, no, it's million. Oh, but it has a bunch of tokens on it. Yeah, wow. yeah. Fun fact: you can just if you see Jacob's comment here, that's a link to a blockchain explorer. It allows you to visualize the blockchain data of Ethereum in real time. And so you can actually check out what's happening without necessarily having to download the blockchain in your computer. So that's a pretty cool feature. And yeah, you can just play with lots of fun stuff. You can just see how many people are just sending money to this dead address. And fun fact, nobody owns this address. Like nobody holds the keys, the password, let's say, to this account. Like in Ether, you can send money to any account, but you could also send it to an account which doesn't exist, and therefore, technically speaking, you're just throwing away money. So yeah, how is the exercise holding up? I'll be very hopeful if whoever is ready or whoever isn't ready but would like to get some feedback, please copy your code, upload it to Pastebin or somewhere where you can share it with a link, and then send the link to whatever platform you're watching this on. Sorry, not platform. Just post the link on the Slido, and I really want to take a look at it. I really want to give you some live feedback on how this exercise is holding up, and yeah, I just really want to interact with you. It's super difficult to do these workshops with just sitting on some dark room here at almost midnight in Europe and just keeping motivated to talk in front of the screen. So help me out with this and help yourself out as well. Someone asked, how is the real money converted to digital currency? That's a pretty good question. Technically, it isn't converted directly. Let's take a look at the coin example, right? So I've just got my program with some numbers in it, and I call this a currency. And what happens again if someone actually wants to hold my currency? Well, they would have to buy it from somewhere, or more precisely, they would have to convince someone else that already holds this currency to send them some of that currency. And how would you convince them? You usually pay them, for example, US dollars, or you would pay them something they want. And congratulations, you have a market. That's basically how cryptocurrency exchanges work in general. You don't have a direct transition between dollars or euros to crypto, but you've got people willing to exchange to give you crypto for euros, and you've got people willing to give euros for crypto, and you've got a price. And they call it currency, and people invest in them, and yeah. So the questions box seems empty right now, so please feel free to shoot more stuff. Otherwise, I could go quiet for a few minutes, let you finish up your exercises, and I could go back in, let's say, 10, 15 minutes, and then see what's up. But in the meantime, I'll be monitoring the Slido. I really want to see some contracts there, some code, some Pastebin links. Even if it's not done, if you're doing it, please share it with us. And yeah, once I see that 1, 2, 3 people have completed the exercise, I'll just move on. And I'll show you a more complicated contract example of how you can hold an election, the ballot contract that I just showed you a screenshot of, but I'll show the actual code and how it works. And then I'm going to introduce the last exercise. That's a challenging one that you can do after the workshop if you so desire, and if you really want to become pretty strong in that area. So someone asked, is message a default variable? So technically speaking, it's not a variable. A variable means something that can change, something that you can assign values to. Messages like msg.sender, for example, just gives you block data. You've got other things like message.block number, or I forgot the exact expression, but you've got lots of other message.stuff that you can access information about the current context of the blockchain or the current context of the execution of the smart contract. It's not a variable, but you can assume that you have access to it anywhere. Like it's just given to you by Solidity. Okay, I'll turn off my camera for a few minutes, but I'll keep watching the slide. I really want to see some contracts before I proceed, because what else am I proceeding for otherwise? So please send them, and otherwise we'll be back very soon. Hello, hello. So I'm seeing that someone already submitted their code. So let's just review it and give some feedback. And I really hope to see more of you do that. And very convenient that person decided to be anonymous. Okay, so I'm going to just copy their code on Remix, and I'm going to share my screen. Okay, cool. So let's take a look at what they wrote. So they're defining a variable for storing the owner. That's pretty good. And also the counter. Technically, because everything's by default initialized to 0, you don't really need to specify counter equals 0. But I realize I recognize that sometimes making it explicit is useful. It doesn't really change much here. Okay, so what are we seeing here? Well, we're seeing a getter function, just returns the counter. Pretty cool. And an increment function that requires that the caller is the owner, and it tries to do some overflow checks. That's pretty good. However, first thing that can be improved here is that you never actually set the variable of the owner. So how does Solidity actually know who's the owner? In fact, by default, the owner is going to be 0 because you don't set it. So you would need to do something like you need to define a constructor and then say that the owner is the caller of that constructor. You've got to initialize it. Okay. So now it could work. In fact, once you write your contract, always run it through the virtual machine heroes. Run it through the virtual machine, and try to see if you can make it work. Try to test every case that you're coding for. It's very useful. For example, the way this person did overflow detection. Now let me just give some background in case someone's not familiar. Integer overflow is when you reach the maximum value of the integer. And once you reach the maximum value, and let's say you add 1 to it, you go back to 0, or you go back to its minimum value, which if it's an unsigned integer, that's 0 in our case. So what this person's what this person's testing is if counter plus 1 is less than the maximum type of this integer, and they Googled and they found that this is the way to get the maximum values. That's actually correct. Then they throw an exception and says overflow detected. That's good. There's one problem with this, that counter plus 1 is an expression, and that expression has a type of uint256. Therefore, because it has that type, it cannot be bigger than the maximum value for that type, right? So this expression will always be true, is what I'm saying. Even if you're reaching an overflow, because if you are the maximum value and you add 1 to it, you're going to be back at 0, and this expression will still be true. So there is a different way to check for overflow, and and this way also doesn't actually rely on you accessing the max value of that integer. I'll let you figure it out by yourself, but you're on the right path. So good job for that. And again, same here. This expression will always be true. This variable, because it's uint256 by type, by default will always be less or equal than the max value. Cool. But yeah, you increment time under the counter. Well, that's it. The only thing that I would change here is you see how you've declared the owner and counter as public. So what's going to happen if I compile your contract? I'm going to select it. And something didn't compile correctly. What is it? I have to add parentheses. Yes, I forgot the parentheses in the constructor. Cool. So it compiled. Let me just run it then. I'll just deploy it here. I'll remove the coin. So okay, so that's demo 1. You see how you already have a counter function because you made this variable public. So I can just get the counter from here. You don't necessarily need to add an extra function. I can get the owner, and the owner is, oh yeah, now the owner is me because I added this constructor. And can increment the counter. I call increment, I call the counter, and then now the counter is 1. I call increment a few more times, now the counter is 4. And what's going to happen if I change my accounts? I'm going to change my accounts to this one. Okay, so that's not the owner. Okay, so I'm going to increment, and the counter is still 4. I'm going to increment as many times as I can, but the counter is still 4. Okay, so yeah, works. Let me see if anyone else. Okay, we're seeing someone else's code. That's beautiful. Thank you for sharing this. Let me copy over that code. Wait, had I not shared my screen a few minutes ago? I'm not sure. So did you actually manage to see? I'm not sure. I'm not sure what part of the previous contract that I went through did you manage to see? Or okay, whatever. Let's hope that you managed to saw everything. That you managed to see everything. Cool. So that's the new contract of someone else. So let's take a look at what's happening here. So we've got counter, minter. The counter isn't public, so that means you need to have your own getter function. Okay. So you call it a minter. We could call it an owner. Here will be more relevant because minter was in the context of a currency. Minter is the person who mints. A mint is the act of creating new currency out of thin air. But it's all right. So you correctly set the owner. Okay. And then you have a function to increment the counter, not just by 1, but with a specific amount. Okay, you correctly did the check for the minter. Beautiful. And then you okay, I see. You're trying to add the amount and then see if this is less than some particular number, some pretty big number. And if it's less than it, then that's good. Cool, but yeah, you don't necessarily need to actually do a comparison with a fixed amount. In fact, all you could really do is compare it against counter itself. Okay, so if this expression, and therefore, let's say the equation needs to be on this side. So if counter plus something is bigger than counter, then we didn't really reach an overflow because it's bigger. Otherwise, if we did reach an overflow, then counter plus something would be, let's say, 0 or a very, very low number, which would be smaller than counter. Okay, so this is how you can check for integer overflows. Now, again, you don't really have to do this right now in Solidity. The new version of the compiler by default does it for you. So they actually throw exceptions if something happens. So technically, only this line 15 here is necessary. Okay. So so somehow we got a comment here that this function is not working. So why does it not work? It should work. Let's see. Let's just compile it and let's test it out. Okay. Let me just clear out the previous contract. Counter, deploy. Okay, I deployed it. Okay, so I'm gonna get the counter. It doesn't return anything. Okay, let's see. Oh, I see why. Remember what I said about the view keyword? That you need to add the view keyword to every function which doesn't change the state of your contract. Now, I forgot to mention a very important detail. I said that it's only for efficiency, but it's actually quite important because if a function is not called, if a function returns something but it's not view, then you actually, as a person calling the function, you won't get the return data. It's just a limitation of how Ethereum works. So if you add view here, okay, and if I go and recompile and I redeploy, okay, now this get counter function will be blue, and when I click it, it's going to give me my value back. So again, you should put view on anything that doesn't change the state of your contract. Cool. Minter, that's me. I'm gonna add 10 to the counter. I'm gonna add 10, get counter 10. Beautiful. It works. I'm going to add. Actually, I could add a pretty big amount. It's still gonna work. And yeah. Cool. So yeah, it works. Let's see if anyone else has shared anything. Otherwise, we will move on. Okay. We've got another submission. Yeah. Let me just copy it over. Okay, so that's the third one. And it does seem like the most fleshed out one, maybe because the person sells some of the feedback so far, or maybe because they just did it. If that's the case, congratulations. So what are we seeing here? Again, count and a minter. I guess could be an owner. They're public, so you don't really need a getter function for it. So get count is not technically needed. So you said the owner correctly. You check the owner, you check for the overflow. Yep, looks good. And you increment it. I'm not gonna really run the code. So wait, can you see my screen? Because someone from my team is telling me that I can't. All right, could be just my connection. Could anyone confirm on the slide that you can see my screen? Hello? Earth things moon. Let me try again. Okay, Marcus, can you confirm that it works? Beautiful. Cool. So let me just quickly go over a more complex contract example. I'm not going to have the time to actually demo it, but nonetheless, let's just take a look at the ballot contract here. We're seeing a ballot contract in Solidity in Remix. You can access the same one. You should be able to. Let's just see something slightly more complicated and slightly more practical. How does it work? And with slightly more Solidity features. So as always, contracts always start with their state. And here we want to run an election. So we need to store different proposals. And we have different people who have the right to vote. So clearly we need to store a profile for every person who can vote. So we're defining a structure called voter. A structure is just a set of different variables. So a tuple of elements technically. It just has all these stuff in it, nothing more. Okay. And we have a structure for the proposal. We hold the address of the owner. In this case, the person who created the contract. We call them the chairperson. This person has more special privileges in the contract. We have a mapping because these structures just defined the type, voter and the type proposal. They don't actually store it in memory. So we have a mapping that maps the address of a voter to a particular voter structure. Okay, so this is how we store all the voters. And because the proposals are only a few and they're numbered, as in they're just 1, 2, 3, 4, right? We can just store them in an array, and this is how you can declare an array in Solidity. Notice this array doesn't seem to be of fixed size. Arrays in Solidity by default are dynamic. In fact, you just can't really have fixed size arrays unless, okay, you can, but that's a bit more advanced topic. So yeah, you define an array of proposals, and that's it. Cool. So let's see what goes inside these structures. So first of all, we want to know if someone actually voted already or not. So if we have a Boolean flag, true or false, if the person already voted yet. We also want to store what they voted for. And let's say we can store these votes as the index of the proposal. Because we have a proposals array, so that means every proposal has an index in that array. We can just store the index of the proposal for which this voter already voted. That's it. We also want to support delegation, meaning we want to give the ability of someone to delegate their vote to someone else. Okay, so we need to store that. So first, if a particular person delegates to someone else, we need to store who do they delegate to. And if, let's say, someone is being trusted by 5 people, so 5 people give their vote to them, we need to also somehow store this in our contract. So we can do so by having a vote weight variable for every voter, which by default is 1, meaning every voter has one weight. But if 5 people delegate to this voter, for example, this weight is going to become 6, the vote of the person plus the 5 delegated votes. This way we can keep track of delegations quite easily. But again, that's just only the memory. Every proposal, it's quite simple, it just has a name, and it has a number of votes which it received. Pretty simple. The name is of type bytes32. It's just a generic variable that is 32 bytes, and if you want, you can store text in it. Okay, so we got a few more functions here. We'll very briefly look over them. So we got a constructor. In the constructor, we actually initialize different proposals. So that means once you create the contract, you have to, as you create, you have to add all the proposals in the constructor, and that's it. No more proposals can be added after the creation of the election contract. Okay. So we're just adding all the different names of the proposals here. We're sending the chairperson. We're sending the vote of that chairperson to 1. So voters, again, is a mapping. Chairperson is an address. So this points to a particular voter structure. And that voter structure has a weight field. So we can just say that's weight to 1. And again, because it's Solidity, we don't have to initialize things. We don't have to say equals voter something. Like, you don't have to initialize the voter structure. By default, everything's 0. That's fine. Okay. Then we run a traditional for loop over every given proposal name. And we take the proposals array. We push, meaning we increase its size by 1 by adding a new element to it. And the element that we add is this thing here. Okay. So we actually create a new instance of the proposal structure. And this is the syntax that you do that. So it's the name of the structure, and then for every value, for every variable in that structure, you just add its the particular value. So for name, this is the particular name, and then vote count 0. So you just initialize all the proposals in that array like that. So that array just holds everything, and it's good. Okay. Now, so far, by default, I said everything is initialized to 0, meaning this is false, meaning nobody has the right to vote. So we need to give people the right to vote. So we've got a function that takes an address of a person, and it gives them the right to vote. But this function must only be called by the chairperson, okay? Because otherwise, everyone could just give the right to vote to anyone else, and that's just a bit too much. So the chairperson only has the right to do that. Okay, so first of all, we have to check all the cases in which our contract may be falling. Like, we really have to think about every situation in which this function might be called, and we want to make sure it only does its job when it should do its job. So we have to check many cases. So for example, even if the chairperson is malicious and they're trying to do something weird, this function should prevent it. What does that mean? Well, first of all, if we're trying to give the right to vote to someone who's already voted, well, why would you do that? If they voted, they already have the right to vote. So we shouldn't, we shouldn't allow this. Okay. And also, we should make sure their voting weight is 0, which is by default, right? If it's 1, that means they have the right to vote. So it must be 0. Okay, both of these statements are true, meaning they pass. That means a person never voted and never had the right to vote. So we'll just set their voting weight to 1, and now they have the right to the right to vote. Next function is how you can delegate your vote to someone else. It's a bit more complicated, so I'll just skip it in the interest of time, because we got literally 7 more minutes left. But don't worry, we're pretty much done. The most important function here is the vote function. So it can be called by anyone with the right to vote. Okay, it takes a parameter, the index of the proposal for which you want to vote. Okay, so let's start with this function by taking the voter variable of the person who called the function. Okay, so we create the sender variable, so we can refer to it later. So we have to check, first of all, the sender's weight has to be different from 0. Otherwise, they don't have the right to vote, and they must have the right to vote. They also shouldn't have voted already. We don't allow double voting, right? So they must not have voted yet. And if both these statements are true, then we just say that they have voted. We say which proposal they voted for. And we also go to the proposals. We take the proposal of the particular index, and we increase its vote count by the weight of that voter. Again, which is going to be 1 if this person just has the right to vote, but it can be more if someone else delegated their vote to that person. Okay? And that's literally the whole election. Everything else is just 2 functions which allow you to get to read which proposal won the election and what's the name of the proposal which won the election. Again, pretty self-explanatory. But yeah, go as an exercise after the workshop. Go take a look at everything here. Play around with it, simulate it in the virtual machine. Play with it from a few accounts. Try to break it. Try to vote twice. Try to vote from someone who doesn't have the right to vote. See what's happening. It's quite interesting, and the virtual machine here is quite powerful. Okay. Now I'm gonna quickly present the challenge exercise, and then we're gonna end off. Okay. So I want you to create a decentralized domain name system contract. So a DNS is something that resolves, for example, hackthenorth.com, so the IP address of the server, so that your computer knows actually what to reach. Okay, so we're going to make it decentralized, meaning it's going to be, in the blockchain, super secure, all. Okay, so I'm going to put a few requirements here, mostly functional requirements. Like I'm not actually going to tell you how to do it. Okay, so I want this contract to allow me to buy a domain name. Let's say domains are just strings. Okay, just some string. Okay, the price of that domain is 1 Ether. Okay, it's not some random coin currency. It's Ether in Ethereum. Okay. And you cannot buy it if it's already bought, right? So you should look up how can you actually operate with Ether from smart contracts, or you can just contact me on Discord if you don't know where to start. Okay. Then for anyone who bought a domain name, we should give them a method to change the IP of that domain. For the sake of simplicity, we can just use integers as an IP address as a type. Because let's say we're not actually using a real IP address here. So we could just set some integer, that's it, okay? And clearly, if it's a DNS, it should allow anyone in the world to get the IP of a given domain for free. And also, if you read about how contracts store Ether, you're going to realize that if a contract accepts payments in Ether, they're going to be stored inside that contract. You need some methods to actually transfer this money out of it to your personal account, for example, if you actually want to use this money for something. So you need a method for that. Okay, and let's say domains can't expire. That's it. Again, if you keep the link that I sent in the chat to that of the document that had both exercises, you're going to see the same text over there. So just keep it as a reference. Okay, and otherwise, I'm super grateful for having had you tonight or today, tonight here, or tomorrow already for me. And you can contact me on these things. Most importantly, I just want to reach out. I just want to point out two things. First, please open a slideshow. We're gonna open a feedback poll right now, and I'll be super grateful if you can fill it in. It's gonna be super helpful to actually see how I did. I'm not very used to be teaching remotely, so I really want to understand what can I do better, what can I learn from, but also in general as a Hack North, as an organization, what could we do better here? Just open the poll. Should be live very soon, or if not right now, and please fill it in as much as you can. It'd be super helpful. Okay, just give me some feedback. Okay, I'm just sitting in front of this computer screen, talking at apparently something super silent. So show me that something is alive. And also, if you want resources, check out the Hack Pack. Okay, the link is over here. It's also in the Hack North schedule. Okay, my.hacknorth.com, whatever /schedule. A Hack Pack is full of super useful resources if you want to keep on getting inside the field of coding Ethereum smart contracts. It has links to all the important documentation and lots of cool software tools. How can you integrate smart contracts on your web application? How you can how can you write a normal code like a server application that can interact with smart contracts and other things. It's full of phone resources there. Check it out. And also on my previous workshop from yesterday, you can find it on the Hack North schedule, the recording there. Again, it's super critical if you want to actually write contracts and if you want to actually deploy them in the real world. That workshop also has a hack pack, okay? And that hack pack is also super rich of resources for you to learn more about blockchain from a more theoretical perspective and how it works, okay? Otherwise, again, please fill the feedback poll. I'd be very grateful if you do that. And I'll be checking out some questions in just a few seconds, but I just want to keep the slide open for you to check out the links in case you find them difficult to access otherwise. Okay, I'm seeing there are some questions coming up, so I'm going to take a look at what's going on. So I'm seeing that someone asked if I could share the voters contract code. Now, if you open Remix, you should be able to see that contract by default. It should be called ballot. You should be able to find it somewhere. Remix should come with 3 contracts by default. So this voting contract should be there by default. Okay. Any other questions? I'm seeing a few people filled out the survey, about 4. Come on. I'm sure there are more people watching right now. So I hope more people are watching right now. So please do fill it out. Okay. Otherwise, I'm super open to your questions around the exercise. Let me send you the link to the exercises again, in case you lost it somewhere. And otherwise, I'll be watching the Slido for a few more minutes, and I'll call it a good night for me and a good day for you. Someone asked, will I be available throughout the hackathon for questions and to talk in general? So yeah, generally speaking, if you manage to message me or over an email, for example, would be easiest for me. Yeah, I would be able to respond to you. We could jump on Discord, for example, and yeah, if you're interested in feedback, if especially I'd be super happy if you did a challenge exercise and then I can walk you through a better solution, or maybe feedback on your, yeah. But email me as the most reliable thing, as the most reliable way to reach me, and I'm gonna send you my email in the chat now so you can have it. Otherwise, you can always go back to the recording and take a look at the context slide and see how you can reach me. Otherwise, how many answers to the poll? Okay, 5 answers now. Come on, you can do a bit more. Otherwise, it seems like we're going to be ending off a bit 4 minutes late, but it's all right. We finished the slides on time, so that's good. Nobody's going to beat me up. So again, for anyone who's watching, I'm super grateful that you stayed up until the end. I'd be super happy if you follow through the challenge exercise and you let me know how you did. We could schedule a short call, see how it is, especially if you're planning on actually hacking with this, doing a project or something. Again, watch the previous workshop. Let me know what you're trying to build. You never know what kind of advice you could get. Otherwise, I truly wish you an incredible day, and yeah, see you around. Bye bye.